Until graduation did not understand the principle of brushless motors turned out to be so simple. Compared with brush motors, it has the advantages of low noise, low energy consumption, high safety performance, low maintenance costs, and so on. So it has a wider range of applications. When we talked about brush motors, we said that if we use a metal bolt to wrap a few coils of insulated wire and then energize the wire, the bolt becomes an electromagnet. It has the same properties as a permanent magnet. When they are close to each other, they are attracted to opposite poles and repelled by the same pole. And when you change the direction of the current, the polarity of the electromagnet changes accordingly. In order to keep changing the direction of the current, so that the electromagnet can keep rotating through the interaction force of the magnets, brushes were eventually introduced. This is the brush motor. Now that we understand this, let's look at brushless motors. Brushed motors have friction in the brushes, so there is a lot of noise and loss. Friction fire, poor safety. So we simply remove the brushes and leave the electromagnet fixed. Instead, let the permanent magnet is not connected to the wire rotation. It cannot be, as you can see in the picture. The three colored coils in the motor are actually three electromagnets. When one of the coils is energized, it becomes an electromagnet and has magnetic properties. To make it easier to understand, we label each of the three sets of coils with a serial number. Because opposites attract and opposites repel, the permanent magnet is attracted to the position of coil 1. At this point, coil 1 is de-energized and coil 2 is energized. The permanent magnet will continue to be attracted, then coil 2 is de-energized and coil 3 is energized. When it reaches coil 3, coil 1 is energized. But at this point, because the polarity of the permanent magnet is different, the direction of the current in coil 1 will be different. And then it continues to attract and rotate. It's like dangling a favorite carrot in front of you to attract you to keep running. But this is not efficient. The rotation is not smooth. At this point, we can energize both sets of coils at the same time, and then the permanent magnet will be pushed by one of the two coils and pulled by the other. It's like having a dingo chasing you again. It greatly increases the power of the motor. But how does the motor know when to energize and de-energize which coil and control the direction of the current? Actually, it's through this Hall sensor, which detects the exact position of the rotor magnets and passes it on to the electronic controller. This determines which coil to energize and in the right order to maintain rotational motion. It's a bit of a brain teaser. Let's not get into that. All you need to know is that the control process is regular and computerized. Okay? Did you learn it after watching?